Alright, so welcome back. Let's have a look at how I've done the collisions for the rigid pieces. This collision, uh, well, it's nothing really fancy. It's just a lot of uh, converting to SDF and back to polygons. So, so all I've done was just take these fractured pieces, including uh, the rigids as well. So all I'm doing is just time shifting the rigid sim points to be at their final position for the simulation. And I'm doing as well blasting off the inside pieces of the fractured geometry, and isolating all the faces that are just pointing up with their normals. As you can see on the delete top, you can delete things based on their normals. All right, and then transforming these to their final position. Because all I need is just the bit of for this frame, the center bit of that frame, and this part here is just to create, because we got a lot of gaps in the pieces and we can't really get a good VDB from having too much holes on my mesh. So all I done was just connect adjacent sub, scatter a bunch of points onto these, and this clip is just to make sure I'm not adding too much points below. I don't really need stuff below. And then converting that into a VDB from particles, reshaping it, and then back to polygons. And there you have it. That's my crater collision. Next would just be creating the extra ground stuff, since the ground is just a flat grid that's laying down on 0 on the y-axis. I could just literally recreate it using a grid, and this attribute wrangle is just creating a mask from the centroid of the input geometry. So I have a mask here, mask center. You can see this. Why do we not have that mask center attribute? Oh, it's a primitive. Right. Primitive, and there you go. So all it's doing is just getting the centroid of all it's doing is just getting the centroid of the input geometry and calculating the maximum and minimum of the bounding box of that geometry and computing the distance between the minimum and the maximum. And you can recreate this with just using, sorry, not that, mask along geometry using this node. If you just put mask center, this attribute will be on the points, so it's gonna promote that from points to primitive, mask to center. And if you visualize this, we have to specify the start points for this guy. So all I'm doing is just selecting the points, and if you have a look, now we get that mask, and then we increase the radius and somewhat the same. Then Perfect. So that's the easy way to do it, and you don't have to follow this code. It's not important much. Cool. So all I'm using that thing is to just blast off the center part, and obviously getting in that collider geo we had from the rigid bodies, and now we have a full collision mesh. Merge them all together. We got that. Perfect. And yes, we also need these collisions from the environment. So all I've done is just create these SCFs for those. Yeah. And next up, finally, the vellum solver. This is where the magic thing happens. All right, let's have a look. I'm just checking why we have animation here. Oh. It's the, what is this guy animating? Oh, well. Alright, so if you can see what we've got on the final result, we've got this kick up and then a spiral spin thingy. So much like the embers on the blue stuff, I was using some pop axis force, the pop wind, and some, yeah, all these good stuff that we've talked about on other setups from the blue stuff. But I think what helped the most was this top solver deform. It's really nothing special. If I show you for a bit what it's doing, and this apply sim state is just to fetch the animated stopped and pin to animation attributes that we've made up here. Modify sim props. So inside the top solver deform, all I'm doing is literally just point deforming the grains based on this deformer. So it's just this kind of grid based lattice, and twisting this lattice along the y-axis. The points will get deformed from this, and on this wrangle, I'm just saying, hey, let's blend to that deformed state based on some animated parameter, if you can see. And this blend is not uniform because I have a random multiplier here just to mix between just to make sure we don't have that clean deformed look. So if we just grab all of these and copy all that, and then we'll get these guys. Let's create a pop network, or let's just grab a grid. Resize it, and simulation 1001. That's fine. Go in here. Let's create a top solver. All right. I'm just using a popnet so that's faster for us to visualize what's happening. So this is scattering on the grid. Just gonna tell it to have a lifespan of 2, 1, and let's add to inherited velocities 0 0.2, 0 0.2, 5. Let's have a look. That's cool. So any moment now we'll see a twist, I think. All right, so that's cool. So what I want to do in this solver, we can see it twisting. Yeah. We've got this cluster ID that we don't have specified into our points, so I'm just removing using the point IDs. And if you have a look, some points will be following more on the deformation, while some points will just keep to what they are already. So that's that for this R thing. Another thing that I want to mention is they don't get correct velocities. So as you can see, so I'm gonna recompute the velocities here. Compute velocity. It's backward difference. Now we'll get probably have to match by attributes. All right. Cool. So all I'm doing here is just this R is just a random factor based on the particle ID, or in the grains ID I used to use the cluster ID. And this mask is to say how far from the impact point do we want to be affected by the deformation. So all I'm doing is that I don't want particles that are too far from the impact point to start deforming. I want to have a nice natural fall off to say, hey, if you're this far from the origin, from the impact point, then maybe have less of an effect from the deformation. So this is just a mask based on the distance from the impact point. And all I'm doing from the blend is just multiplying that with the R, which is the random factor, and the mask, which is the distance-based mask. Cool. If you have a look at this guy, the blend, I'm just animating that parameter. Let's put a full force on deformation. Cool. It's not very cool, but yeah, this helped a lot on, I think, on the grains. Where is it? Here. This helped a lot on the grains, but if you do have the time to play around with the pop axis force, I think that could work as well. But yeah, so that's that for the vellum solver. There's nothing special in the solver itself. Yeah, so that's that. So on the next bit is just playing around with all these extra bits of points, particles. I don't know, for some reason, if I had, because I'm killing particles based on their neighbor count that you get from vellum solver for free. So I'm just saying it's an array attribute, so integer attribute. So I'm just computing the length of that array and say if your neighbor is if you have less than 3 neighbors, then just kill. So that's why I'm removing all these stray points and just keeping most of the clustered up grains. So I made a note here saying that I don't get any neighbors if I had this turned on, OpenCL neighbor search. Not sure if it's a problem with this build version of Houdini, or it's just something that it's just how OpenCL works. But I had to turn it off. There were some performance loss by turning this off, but I needed these neighbors to have values in them. So yeah, and cool. This should be the cluster ID. Cool. So this attribute adjust color is a really cool node. If you set it to operation set to always and then have this to random, and on the range values say specific values, and you get these color palettes. It's pretty cool. You get earth, you get subdued, bubblegum. So you can color your particles based on these color palettes. It will randomize the distribution of these colors. And just set this to cluster ID. Cool. So that's how I colored the grains. Awesome. So that's that mostly for the grains kick up, not too complicated. So on the next bit, I think we'll be talking about how I've done the dust kick up points. Just a pop that pops in, it acts like the dust, the dust and the grains and all the stray particles and stuff. Okay, cool. I'll see you in the next video then. Bye.